relevance in other areas as well. I'm going to show some Python notebooks. I do my work in Python. I do everything on SciServer. I have some scripts to get US Census data and put that onto SciServer system, which I've done. And do I maybe have it too close? How about now? Is this any better? All right, I will keep talking, and we'll see if we can do anything to resolve the static. Maybe. Problem is, it was actually too far away and pointed at my shirt. So, trying it this way. Is this any better, Toronto? All right, so the notebooks that I'm going to show you today are right now, what's that, Ani? That is better? Good. The mic was being blocked by my shirt. Great. So the things that I'm going to show today are currently in a shared data volume on SciServer, which you can mount. You have permission to see it because you are all members of the IDEAS Visualization Workshop group on SciServer. Actually, Manu, I think you may not be, so I will add you right after this talk. Is anybody else not in that group? Okay. What are you available? Okay.
So the static is still there. Bonnie's just checking all the connections and changing the batteries. I don't know which batteries. In the mic.
Probably means the microphone battery. All right. I'm going to shut Toronto. I'm going to shut off the microphone for a second. I'm going to check the batteries. All right, the static will be better once we find AA batteries. But for the moment, I am just going to start talking. I apologize for the static, and I hope you can hear me. Everybody in this room here at Hopkins, it's really good to see you. I talked with most of you yesterday. You're all doing some really exciting things. Unfortunately, I need to leave after this talk, so I won't be able to see the results of your hacks. But if you can please put your work in the GitHub repository, which is right here. Just check your code into github.com IDIES Visualization Hackathon. You should have permission to check in. If not, send me or Bonnie an email. Who here has used GitHub before? All right, so a few of you, that's good. And just teach other people how to use it, because I think it's important that we get all of our code into here so that we can continue to collaborate and share and benefit from it beyond today. So what I'm going to do is I'm on the SciServer website now. I'm going to log in. With my SciServer username and password. All right, so this is my SciServer dashboard. Like I said, I have created a group. And if you have an invitation to this group, you'll see it here. The group is called IDIES Hackathon 2019. And the reason that we're using this group is that we can share files. So I have shared 2 folders in here. One is called Baltimore. It is in our storage system, which is permanent. It's always kept. It's always backed up. It's limited to 10 gigabytes. So I keep all of my scripts in here. There's also a temp directory which has some big data sets in it, including one that Ronan and IDIES just uploaded yesterday that they can tell you more about, that I think is pretty exciting. What I'm going to do now, though, is go back home. I'm going to go into Server Compute. So I think by this point you all have at least seen and maybe worked with compute in the process of doing your hacks. What I'm going to do is I'm going to delete this because I'm limited to 3. All right. Toronto, we're just going to switch these batteries. Lived in Baltimore 20 years now. It feels like home. And so it's really a lot of fun to be working with data out of town, and also data that hopefully has some social and policy relevance.
Yeah.
There's Baltimore is a beautiful city. We have a lot of problems, and data analysis on its own is not sufficient to solve the problems in Baltimore. But I hope that it can be a step in the right direction. All right, we got the mics. All right, so what I have done in the meantime is I've gone into compute, and I'm creating a new compute container. There's only one domain to pick from, so that's what I've done. Important when you're working with geospatial data is to select the compute image called geo, because that's the one that has the GIS tools installed in it. So my scripts that I'm going to show wouldn't work if I weren't in this geo image. Another important thing is user volumes here. I'm mousing over so the Toronto people can see them as well. I have to make sure that I have checked the file volumes that I want to use. In this case are Baltimore and Baltimore temp. And I click create, and that will create the container for me. Container, of course, is a virtual computing environment. So I'm going to go into this container. I mentioned before that there is a storage volume and a temporary volume. Storage is the one that's backed up but limited to 10 gigabytes. That's where I keep my scripts. So I click on that. It's under my name because I'm the one that created it. So when you log in and you mount the volume, you will also see it under my username rather than yours. So I click on Radic, and then on Baltimore, which is the data volume where the scripts are. And I've got a number of different projects in here, this including the Baltimore crime data, which is what Ronan and Darius just talked about. Also, we're looking at the Community Reinvestment Act, which is a federal regulation that requires banks to report on what business loans they give to businesses in various places around the country. There is a lot of, so just the backstory of this, if you've read the book Not in My Neighborhood, which is a story of how policies by banks and city government really reinforced segregation in Baltimore, and the effects of that have continued up to today. There were a big weapon of segregation was discriminatory bank lending. So white people could get loans and black people couldn't. Of course, they were able to use that to build capital, and that just reinforced the economic disparities that were already there and have continued. In the 1970s, as a response to this, the U.S. federal government demanded that banks report on the loans that they're giving in cities. So, you know, we at least can check, are they being equitable in the loans that they give out? So this is there's some research here into that. There's also Tomasz Budivari from our group here and at the computer science department is looking at identifying vacant properties in Baltimore, which often include buildings at risk for condemnation and collapse, seeing if he can help the city government identify these places from various data sources. I'm going to just quickly show you about the structure of neighborhoods in Baltimore, because I think it's a really interesting thing. And then once I do this, I will talk about what it looks like to bring in data here. This is a Python notebook, which was in that container. You can run it yourself. What I would recommend is we don't have simultaneous editing in SciServer. So anyone can edit this file, but only one person at a time. So I recommend you make a copy of it and then work with your copy. Ordinarily, I would run everything in this script, but to save time, I'm just going to show you what I've already done. So think of it as a cooking show. You're seeing the recipe, you're seeing the ingredients. You don't see the time it took in the oven for it to cook, so you don't see the processing time to run this. It's fairly short. The whole script runs in one cell after the other in about 3 minutes or so. I'm just going to show you what I've done. So first, I import the packages that I need. This is Python. Python is a fairly thin language that relies on importing packages to do the things you want to do. R works similarly. So I've imported everything. And then I read in the geography, which is in the form of what are called shapefiles. They have the abbreviation .shp, and they're provided by the organizations that report geographic data. So, for example, I got mine from the U.S. Census, and they're basically spatially aware polygons. So I don't know how well you can see this, but there are lines here separating different neighborhoods in Baltimore. Each of these is basically a polygon that's being rendered by PyPlot, But it's aware of its geography and it's aware that it's on the surface of the Earth. So I can reproject this into a different map projection. I do that projection management using a package called GeoPandas. And I'll put all these scripts in here, and if you have questions, send me emails. Yep. The shapefile is, it's actually a collection of files, and it's a few megabytes. I'm also working with census data. Of course, the data is gigabytes because they ask so many questions. But I'm not at that point yet in reading things in. We have this traditional way of defining neighborhoods in Baltimore. Like, for example, just to the east of here is Hamden. Hamden's a historic neighborhood, has a strong sense of regional identity. Just to the west, just to the east of here is Charles Village, which is right next door, but it's a very different neighborhood. The problem is that the U.S. Census data reports its data in census tracts, which are not lined up with the neighborhoods. So as a workaround, the census and the city government have created what's called community statistical areas. So, and here's a map of those community statistical areas. And they're just a little bit too big to say anything about specific neighborhoods, but you definitely can say specific things about different parts of the city. So, for example, we are right here. I think we're technically in this area of Medfield, Hamden, Woodbury. Whereas if you look at traditional neighborhoods, which I've got up here, you see, first of all, there are a lot more of them. And then if I zoom into the area around Hopkins, you know, in the community statistical area model, all of this is one neighborhood. The lived reality of Baltimore is there are several neighborhoods there. But it's the groupings of the neighborhoods in community statistical areas are diverse enough and interesting enough that you can still do a lot of good work with them. So I just want to make people aware that there are different ways of defining geography in Baltimore City, and just be aware of what geographies you're using. Of course, there are other geographies available, like zip codes and congressional districts, city council districts, and so forth. And there are shapefiles available for all of those, through some through the census, some through the Open Baltimore website, which I believe is just openbaltimore.gov. They have a lot of really great data sets from the city there. All right. I'm going to actually switch to a different notebook now. But any question, and again, this is an illustration of how the boundaries don't always line up. But again, the community statistical areas give you some pretty interesting analysis. Any questions about what I've shown so far? Yes, yep.
Is there a way to create that shapefile for neighborhoods? Because you seem to have like sort of the lines drawn. Is there a way for that?
Yes.
To say like, I really want to look at it, but
Yeah, that's here in this, in the Shapefiles directory. I have this under the neighborhoods full file. That comes from the city. I think I got that through openbaltimore.gov. A lot of the data sets are by community statistical area, though. So I want to show you one more thing, which is how do you use these geographic areas to do an analysis. And we're going to look at health data. And this is data from the Baltimore City Health Department called the Neighborhood Health Data Study. And it asks, it gives a series of health indicators for each community statistical area in the city. So, for example, it reports the average lifespan of residents in that area, infant mortality rates, rates of smoking, rates of school attendance, how many or what percentage of students miss more than 10 days of school within a year. Also, 311 calls. How often do people in that neighborhood call 311? So I've graphic, and sorry, also one more thing. What I'll show you here is mortality rates for various diseases, death rates, mortality and morbidity. So you can look at causes of death in different areas of the city. All right, I am going to need to run some code here. So I'll bring you up to the point where I show a map of, I think I chose diabetes, death rate due to diabetes within the community statistical areas of Baltimore. So I'm going to run these cells. These work? Yep. All right, so we're looking at let me make this a little bit bigger, both so that people here and people watching through the video can see it. These are statistical areas in Baltimore, and the mortality due to diabetes per 10,000 people in that area. And I just picked 3 random rows, and you can already see a huge difference. Washington Village, Pigtown, is traditionally a poor white neighborhood in South Baltimore that's been rapidly gentrifying and richifying. And this is their rate of death due to diabetes, 2.4 per 10,000 people per year. Mount Washington Cold Spring is in North Baltimore. It's a much richer area, and they have almost like 8 times lower mortality rate due to diabetes. And these neighborhoods are only about 5 miles apart. And so it really shows you the tremendous disparities that we have in Baltimore. And of course, if you look at any other large city in the US or anywhere in the world, you'll see similar disparities. So again, just 3 random rows, we can already see some big differences. But if I actually make a plot, and again, this goes with what Mugdi was saying yesterday, that you can already tell just by looking at a table of numbers that there are interesting results. But by looking at a visualization, you can gain so much more insight so much more quickly into what's going on. All right, I'm going to have to make this a little bit smaller. So I don't expect you, all right. So I don't expect you to be able to read and interpret this graph immediately. But the takeaway here is, like I said, there are tremendous differences between mortality to diabetes or any other disease in different areas of the city. This is a color scale. Plot scale is down here from 0 to 7 deaths by diabetes in different neighborhoods. I'm not sure what's going on in Pimlico, Arlington, Hilltop. That I need to explore that a little bit more, because it's a poor neighborhood, but it's not the poorest neighborhood in Baltimore. So I don't know why they would have a significantly higher rate of death due to diabetes. But that's the next research question. Which of course is the great thing about research, is every answer generates 10 more questions. All right, so again, all of these notebooks, including this one, are going to be in that shared container, and I'll put them in the GitHub as well. Yes, Huss?
Do you have a map next to how the city divides the things, so we can see if they are missing if they miscalculate the mortality by how they define the boundaries versus your definition of boundaries?
Oh, I don't have that yet, but because this data is only available at one geography level. But if you have a different health data set, you might be able to reband in different geographies. Is this the? Oh. Yes. Yeah. It's interesting. I don't. I'm pretty new to GIS analysis, so I'm not. I know that's an issue and that there are ways of correcting for it. But I'd love to talk with you some more about it. Yep.
If you wanted to add like another layer of complexity to look at like what was the age of death or the average age of death due to diabetes with something like that, what would that look like in terms of how you do it and also like how you might visually represent something like that? Could you create sort of a 3D effect within that map to say like, okay, so, age was lower here on average, higher here?
Yes, absolutely. Yes, I'll repeat the question. So, actually, I guess I should repeat the last question as well. The previous question was about how does the binning effect work for this data? So, if you chose different geographies, would you see different effects? The current question is, if you wanted to take the next step and say add information about age at death to this map, how would you do that? In terms of coding and getting the data, that's pretty easy because it's just another variable in the same data set. In terms of how to represent it, that's the magic and the thought of visualization, which is what Mubdi was talking about yesterday. So, we can just think and discuss how would you use, say, size or typography or additional data structures to represent that effect in these same geographies. It could be as simple as putting a label on. Like here, I've put the data values in, but you could instead plot put a different variable here. You could add a pie chart or some sort of 3D effect or something. I think that's the fun part of visualization, is figuring out how to communicate the message.
So I think even with the static, this recording was sort of as helpful for you to re-record it later, perhaps?
Yeah.
That's why I think recording questions is also.
Yep. Excellent. Yeah, and this, I'll check YouTube later, and we might want to re-record this. Yeah. Yep. Yep. Yeah, glad to do that. Other questions? All right. Well, I'm sorry I can't stay the rest of the day and see all the great work that you're doing. Today is my wife's 40th birthday, so we're having a party, and I'm going to be there instead. But it's been great. Please check your code into GitHub and just work on your hacks. And Nick will be talking at 3 o'clock, at 1 o'clock. That's right. Nick will be talking at 1 o'clock about some other really interesting research that you can do with SciServer. All right, thanks. Good to see you all.
All right. Can you hear me? All right. Testing. 1, 2, 3. Is the static still there? Can you hear me? Hello? Is this any better? Can you hear me? You don't hear the static that was there earlier? So it's not this. It's not the batteries, I guess. So we checked all the connections, right?
Bonnie mentioned the game. I turned that down during the presentation for a bit, but
Can you turn that on, or will there be feedback, or what? Like, can you take it off the headphones and can we hear it?
the sound.
Yeah. All right, let me see if I can hear that. I guess there's a delay. Ooh, it's a long delay.
Yeah.
Hello? Hello, is the static still there? Hello? All right, the gain is down to the minimum now? All right, put the gain at the minimum setting. Let's see how it works. I hope people can still hear us. Okay. Hello? Can you hear me now? Hello? Is there still static? Hello? Hello, hello, hello? Can you hear me now? Hello? Hello, hello, hello? The channels are matching now. Hello? 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 Hello?
Oh, okay.
Hello?
It's getting the input on here, at least.
Hello? Hello? Can you hear me? Hello? Oh,
Oh, great.
damn.
So back to square one.
Okay, so where is the gain here? This is the gain? Alright, let's try turning the gain down again. Okay, hello. Looks like it's, well, the gain is down now. But I don't know if the static is still there. Hello, hello. The gain is down, hello. Gain is down, hello. Oh, there's this gain too. No, the static is still there. No, I think there is static even when you don't speak. But maybe when the mic moves, I don't know. What is all this? Well, I think we're going to have to live with the static, unfortunately. We will re-record the talks later. The other option, of course, is to go back to Zoom. So why couldn't we do Zoom with Toronto as well?